What's going on, everyone? Sneaky Mofo here. Today we're going to get silly with another Crack Me. I'm taking the difficulty up a little bit from my previous video, so if you are a beginner, you will probably need to go watch that video first. But for everyone else, I'm just going to jump right in here. Now I'm using what is ultimately a very simple Crack Me, but this will give me the opportunity to finish fleshing out the ways you can use Cheat Engine to crack applications. Okay, so this is probably the last one of these videos I'm going to do where I use Cheat Engine exclusively with something like this. But it should like bridge any other gaps that some of you might have with the logic of converting your knowledge from using Cheat Engine for games to using that for applications. Alright, so first things first, whenever you have a Crack Me, you want to see what the behavior of the application is. So I'm going to enter a password here. Alright. Oh, also this Crack Me wants us to do a couple of things. It wants us to patch our name here, and it wants us to find a valid pass, not patch. Well, we are going to patch. We're also going to find the X's and replace our name. We're going to find a valid pass, and I'm going to do a couple of other things too. Alright. So here we see our error message, right? So we're going to want to find that string. That should take us to the place in code around where we can futz with this and hopefully get a success message. Alright, so we see that message, we see press any key to continue. I'm going to do that and the application closes. Okay, that makes it a pain in the ass for us to do what we want to do with Cheat Engine. So one of the first things that I want to do, well, you know, because if you use a debugger like X32, X64 debug, or Ali, you can simply restart an application from within the debugger while it's still attached, essentially. Or it'll reattach itself automatically. With Cheat Engine, we need to kind of create a workaround if we don't want to have to close the app, or every time the app closes, reattach it, all that stuff. If we don't want to have to do that every time, I've reattached here. I'm going to open Memory Viewer, and the first thing that I'm going to do is, since this is such a small application, which, by the way, this is all in the download description below to find all this stuff, everything that we're worried about is all like right in here. Alright, so what you could try to do to find your way to, like, where does this application restart itself? We could go through and find, you know, here's the bad error message, right? So that message is moved into the memory address referenced by ESP here, whatever it's pointing to. Then we have printf called, then we have a pause, call, leave, ret, right? So all in here is where the application exits. So, you know, if we're looking around through here, we see our bad error message, we see a jump, we see this call to printf. Above that is what appears to be the success message. Above that is the very classic case. We've got a jump if not equal. Above that is a test. We have this call to string compare, and presumably two strings passed as arguments to this function. So that's why it doesn't want you to patch it, because this is about as easy as it gets where that's concerned. But anyway, if we follow the logic from our two arguments there to the call, to the test, to the jump, if the jump is not taken, we get the success message. We have the call, we hit this unconditional jump, which goes to here, to this pause. Alright. If our password presumably wasn't good and we jump if not equal, then it's going to go to here where we get the bad message. We have this call, we hit that pause. So no matter what, we're hitting that pause. Okay. Now what we can do is, instead of hitting that pause, let's say we want to, if we enter a bad password, restart this application, or just kick us back to where we can try another password. We have 5 bytes here to work with. This is a 32 byte application here. 32 bit rather. Since this is 32 bit, we need 5 bytes to do a jump. So we're just going to look up through here and we can see where this, the entry point of this, I guess, subroutine ultimately for this application. We can go view and do referenced strings, which will run the dissect code routine, and we'll get our strings here, but it'll also show you things like where a call comes into something, or where unconditional jumps are, blah, 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 right? Well, what we want to do is right here where all this is entered, we want to remember this offset, 1290. So I'm going to go after the bad message, I'm going to go here where we have 5 bytes to work with. I said 32 bytes earlier, that's hilarious. And I'm going to go jump to ltfft.exe plus 1290. Alright, so now watch this. Cool. The other thing this does for us is if using Cheat Engine, and we have a scenario here where this application restarts itself, if we patch these X's, we wouldn't be able to see that because all that's loaded. If we change it in memory, it doesn't change it on the screen here. So if we entered a password and it said press anything to continue and it closes the app, we can't see our change there. So that's where you would need to like permanently patch this application for that change to be reflected. But since we've made our change, every time we do this, it will reload that, right? So now what we can do is view reference strings, and here, whenever you look at a reference string, you have two things. You have, if you double click here, it takes you to that in memory where you can actually modify that itself. Or you have a reference to where like that's accessed in an instruction. Right, so if you double click that, we go to the instruction that has something to do with that string. Well, we're interested in memory down here. We want to change it. So what we can do is go to like ASCII to hex. I'm going to enter sneaky mofo, convert. All right, get those bytes. I'm going to paste those here and look sneaky mofo XX. I'm just going to zero those X's out, and then we're going to enter gobbledygook and look. Boom, cracked by sneaky mofo. So we've done that. Perfect. So we've got this application restarting like we want. If we enter a success message, presumably it will restart. So you might want to do something like do that same thing after the success message. But if you do that, the problem right now, if we do it like at this call, is that we'll never see well done, have you patched your name, because this gets that gets moved into this address that's being pointed to at ESP, but we won't get the printf, so we won't see it on the screen. It would just restart the application. So you would either have to do it at a place where no matter what you get, you're going to hit somewhere where you've got 5 bytes to make that jump. Or, this is good. Let's say we weren't thinking about it and we're just messing around, right? And we do want to put it here where this is. I'm going to paste. Okay. Well, first of all, like I said, this is the classic kind of thing where it just compares two strings. Where it says find a good password, this is the good password. It takes the good password, it takes what we entered, and then it compares those. All right. So what I want to do is enter the good password. So DEIBIZ. What's the problem there? What I said earlier, right? We're not getting the success message because that call isn't happening. Well, if we screwed up and we did that, and we're crap, you're like, crap, I didn't mean to do that. You don't want to restart the application and patch those bytes again because maybe you're like knee deep in this. What we could do is set a breakpoint right here after this jump so that if we enter something successful, we should hit our breakpoint, right? So that's where breakpoints can come in handy for stuff like this. So I'm going to enter a bad password and we restart this thing all day long, right? Now I'm going to enter a good password and boom, we hit our breakpoint, right? So execution has stopped and we can look around in registers and whatever else you might traditionally do when setting a breakpoint. I'm going to toggle with a breakpoint. I'm going to resume execution, and so that's how we know we're hitting the good, we're getting past that jump, right? If we wanted to patch this, we could just nop that jump so that no matter what we entered, every time the test happens, we would hit 2 nops, and then boom, we would have success message. Another thing that you could do, we're going to go ASDF there, okay? We've got what we're entering, we've got the good password. Well, if we look at the instructions that are happening, this is moving the good password from this memory address, right? So the module plus offset 4060, whatever that is, moving that into ESP plus 4. Then it's taking what we entered, which is at the module plus offset 4070, and it's moving that into ESP. Well, you could think of this like this is max health, and this is current health. This is the value that's changing. Here's the max one. If you wanted to make a cheat where you would give yourself infinite health, you could maybe move max health into current health. You can kind of think of that as the same thing here. What we're going to do is just change this to that, so that no matter what we enter here, it's always pulling the good password from the location it is and putting it into the 2 addresses it needs for the compare here. So, bam, that's another way that we could patch it if we were patching it. So we've got the good password, we've got our little thing where we're restarting the app, we've seen how you could use a breakpoint, if you screwed up with whatever. And now what we want to do is, I am going to restart everything here. I'm going to restart Cheat Engine 2, which is going to make my screen go black here for a second. Alright, there we go. There's Cheat Engine. Going to restart the app here, the Crack Me. Okay. Now what we want to do is go Attach Cheat Engine, go Memory View. Let's see, View, Reference Strings. It's going to run the dissect code routine. Cool. Okay, if that password is sitting in a memory address, where is it right now? Open bracket, dibiz, whatever that dude's name is, close bracket. It's not in here anywhere. Now, if you're new to cracking applications and you're like, okay, I'm looking for a password, you might have thought this would be it because it doesn't seem to be related to anything. So you might have tried that. And if you had tried it, it would not have worked. So what you could do is, in the app here, well, let's just say we were looking, we got our bad message. I'm going to go there. Right. What you could do is set breakpoints and try to see where, we know that what we enter ends up here and here, and the good password is here. So presumably we could set a breakpoint somewhere up here on a call to see where the password is acquired, where it comes from before it's moved into this address right here. So you could set a breakpoint there. Well, because this is such a small application, we can just look at the yellow line here, right? You see it, and follow that call down to here. Which, because we ran the code dissect routine here, we can see the call. We could double click that and it shows where it comes from. So I'm going to go follow. And then we move into this, and we're setting up a stack frame here, and then we get to this compare where it's comparing 7 to something. We get a jump if greater than, so if it's greater than 7, we get this jump out to here to leave. Otherwise, we flow through all this and we get to this jump back up to this compare. So this is a loop. That's what we have here. We've got a loop. So you can do a couple of things. You can set a breakpoint at the leave and try to see things that update here after this whole loop finishes executing all of its cycles. See what changes. Or you could set a breakpoint like here at the compare, and it'll hit it every cycle of the loop. And you can look at things happen at every cycle. So that's what I'm going to do. I'm going to do toggle breakpoint here. And now I'm going to enter gobbledygook. We hit the breakpoint. We can look at our registers here. And this is where you could follow it through, so you can either go debug and you can click each of these, or step is F7, step over. I'll show you what that is in a minute. Okay. I'm going to start stepping. And this is where you can look at your registers and look for patterns that might happen. Like watch EAX. See how it's 0, 1 at this compare? Step. We get back to the compare, and just after it, well, let's see. Okay, EAX has 0, 1. EAX has 0, 2 here. 0, 3. So at a quick glance, you can look for patterns up in here just to get a quick idea of what might be happening within this loop. If that's not enough, bust out pen and paper or notepad, but I find it faster to use pen and paper. And with each instruction that executes, I'll write down what's going on, right? And that will really help you visualize what's happening. So I'm going to continue stepping through here, and I want you to watch right here. Watch what happens in a second. You see what happened there? We have this open bracket DEI. I'm going to keep stepping through here. B. So we see our password being built here. How is it happening? Well, I'm not going to run through every single instruction here, but basically what this loop is doing, it's taking every individual character from this key, I'll call it the key that the password is being built off of. It's taking each character, loading it, adding 1 to it. So remember, every character is actually, you can see it represented as a hexadecimal value. So like Z is, I don't know, 5-3 in hex, right? It's having 1 added to it. Z plus 1 is an open bracket. C plus 1 is D. D plus 1 is E. H plus 1 is I, and so on and so forth. That's how it's building the password off of this. The confusing part is when you increment Z, it is not obvious that Z plus 1 is an open bracket. So that was a pretty clever way, if that was intentional, of throwing you off. It threw me off initially. But, I went through every one of these instructions to see how it was being built. And here we go. So boom, we hit the jump. We get to the leave. F7, F7. Here, so that call happened, and boom, there's the good password. It's loaded. So that's being moved into an address. This is being moved into an address. We hit the call for the string compare. This is where in debug you want to step over when you hit a call. If I hit F7, I'm going to step into this call, and then I have to step through every instruction. Well, maybe, because that's where you also have like execute until return, things of that nature. So even if you step into this call, you're not stuck with having to step every instruction, right? But we know what this call does, so we could just step over it. So F8, and then we stay here, and this test would be what comes afterward. And then we'll hit F7, and then we know that we have our gobbledygook and then the good password. So this jump if not equal should happen when we hit F7. Yes, it does. Bad, you should work harder. We jump to this call. All right, I'm going to step over this call, or we don't jump to the call, we move to the call. And then after this executes, we should see it pop up on the screen here. Boom, there it is. Bad, you should work harder. We've got our pause that comes up. F7. All right, I'm going to hit F8 to step over this, and then we should see press any key to continue. So there we go. We have totally owned this crack me and seen how it works. We satisfied the original conditions of it and did all our own stuff too. So I hope that this was a good look for some of you who kind of needed this. The next videos I'm going to be doing are going to be like x32, x64 debug, binary ninja. I'm going to start using hex editors for real, and like sysinternals tools, getting into those, and a bunch of other stuff. So give me a thumbs up if you found this video useful. Don't forget to subscribe if you're not subscribed yet. Check out my other videos, especially the Crack Me video I did before this one. And yeah, I will just talk to you all in the next video. All right, take care.